Hey there. So, yesterday you learned about this idea of inequalities. Practice writing some inequalities. The main idea there is that things just don't always have to be exactly equal to each other. Sometimes they are just less than or greater than each other. So, there's still a relationship happening there, but it's not exactly equal to. So for today, we're going to learn how to do a visual representation when these things happen and learn why we need a visual representation and what it helps us with. So to do that, get out page 30. Looks like this. Page 30, pen, pencil in hand. Here we go. Okay, I've said this in your homework video from yesterday, but I'm going to say it one more time. Remember, if you put your left hand up like this, your left hand makes an L. Put it right in front of your face and you'll see it. Your left hand makes an L. If you also tilt that a little bit, then you get a less than symbol. That's something that's helped me all the way since I was in elementary school, just helps me remember them. So if I remember like, wait, what is this sign? I put my left hand up and I go, oh yeah, left hand, less than, left hand, less than. And then I just automatically remember the other one is greater than. So left hand, less than. Okay, so this statement right here, if I read that mathematical statement out loud, here is how it sounds out loud. That says x is less than 5. What I'm supposed to do is I'm supposed to draw a graph for each inequality. That means I'm supposed to show a visual representation for what it means if x is less than 5. Okay, before we're ready to actually draw that, I'm going to come up here to this blank space at the top of my screen, at the top of my paper here. This is a piece of paper. And I'm going to take my pen and I'm going to give myself a few notes here. All right, so I am going to see either less than or greater than. Remember, left hand, less than or greater than. I am also going to see less than or equal to and greater than or equal to. This one should probably be a little more open to really look like what it looks like. So again, I have less than, I have greater than, I have less than or equal to, and greater than or equal to. Now there's going to be a certain visual representation we use to show these things, okay? So one of the first things I'm going to write, and I'm going to write two things next to each of these symbols. So when I write this next thing, I'm going to write it on the top because I'm going to put thing number 1, thing number 2, and then I'm going to have two things here. So the first thing you need to know is that both of these get what we call an open circle. And if you're like, what is she even talking about? I promise all things will become clear in a minute. This one gets an open circle. This one also gets an open circle. Okay, so these two get open circle. Let me show you what I mean and explain to you why on this first example. So that is just about this part right here. The whole idea of open or closed circle, that's me looking at this and deciding, does it have the equal to part on it? No, it doesn't, so I'm just dealing with less than, so this is going to be an open circle. What that means is I look on my number line here, and I see the number is 5, so I come over here to 5. I'm going to zoom in a little because these numbers are really tiny. So I come over here on my number line to positive 5, and I'm drawing a circle on that scale marking, and I need to draw an open circle. So this is how I draw this. Go ahead and draw this with me. I'm just going to draw an open circle right there. Open means do not color it in. The reason that we're not coloring it in is because x is supposed to be less than 5. And as we talked about with your homework yesterday, if it's less than 5, that means it's not supposed to include 5. So the way that we just show that visually is someone just decided, okay, we're going to mark 5 because we have to show that as the boundary, but we're not actually including 5, so just don't fill it in. We're saying 5 is the boundary. You can go right to 5, but don't include 5. 5 is not a part of it. You can go to 4.999999999, but not to 5. All right, so that's what we mean by open circle. And we're not done with that graph, but let me tell you how we show it here. You may have guessed that if you have the equal to part, that means you are including it. You're saying it's less than or equal to. Could be either one. greater than, or equal to. Could be either one. And the way that we show that visually is with a closed circle. This one also gets a closed circle. So for example, this problem, and we're nowhere near done with these, but this problem, because I see, and this is solely about, does it have the equal to or not? So this one, because I see that there is the equal to part there, I'm going to go to 3, and I'm going to do a closed circle, which simply means fill it in. So see that difference there? Open circle versus closed circle. Now, these graphs are not finished. Okay, and that is because when I look at these, so I'm going to write something else next to them up here. When I look at these, I also have to determine whether I am dealing with less than 5, greater than 5. Which numbers am I talking about? So if I say to you that some number has to be less than 5, if I look on this graph, where are the numbers? Here's my circle. Where are the numbers that are less than 5? Would they be to the right on this number line? No, because those numbers go 6, 7, 8, 9. Those numbers get greater than 5. Those values get bigger. So the numbers to the left of the 5 are less than 5. And all of these numbers to the left of 5 are less than 5. So what that tells me is if I see less than, I'm going to do an open circle, but I also know that I need to go to the left. Less than is to the left. Now that also means that this one right here goes to the left, because those are both less thans. So this one would be an open circle to the left, where this one would be a closed circle, but still to the left, because less than, less than. So guess what that means about these ones? You've probably guessed it. This one goes to the right. And this one also goes to the right. So again, this one's an open circle and this one's a closed circle, so that's the difference between those, but they both go to the right because greater than or equal to, so it changes the open or closed, but it does not change the direction. So let's actually finish these graphs. So this one has an open circle at 5, and then it's supposed to go to the left. So the way that I show that, you can draw, some people draw on the actual number line. I find when you guys do that with your pencils especially, I can't even see it. It's hard for me to see. So instead, I'm just gonna draw a little, give myself a little space like that, and then I'm gonna show myself everything that direction. And I draw an arrow because it does keep on keeping on. This is just a picture to show what this math statement says. They fit together. This one says x is less than 5. This one shows x is less than 5. Open circle to the left. Now there's one more really tricky thing that happens with problems like this, because people just want to match it up. And that makes sense. People look here and they go, hey, that looks like that, so it's going to be a closed circle to the left. Not so fast. Just like with our equations, how we always led with the variable, we need to do that with inequalities as well. And this gets a little bit tricky and a little bit weird. So I'm going to draw an arrow down here and tell myself that I need to flip this around. This is very confusing because now I think it's supposed to go to the left. This statement, if I read it out loud, says 3 is less than or equal to p. I don't want to know what 3 is less than. I want to know what's going on with p. So when I flip this around and start with p, do you know what happens? I also have to flip this around. Think of it. If 3, this hand is 3, if 3 is less than p, oh, p is greater than 3. They flipped around, right? So p is greater than or equal to 3. Whenever you have a statement that is backwards, flip that whole thing around. And that includes the inequality. I'm going to say that one more time. If your statement is backwards, flip it around. That also flips the inequality. See how that changed direction? And that's really important. It doesn't change that I have a closed circle at 3. That part stays. But it does change the direction that I go. So if you have the equal to part, you still have the closed circle, but now I know, oh, it actually matches this one, which means I need to go to the right. Okay, I'm going to switch to my purple pen and I'm going to do everything in purple so that you guys don't think that the circle has to be a different color or anything weird mathematically like that. It doesn't. What I have to really focus on, two things. I first decide open circle or closed circle, and then I decide direction. And you know what? Actually, before that, I'm going to go through here and I'm just going to look for those tricky backwards ones. I notice this one is backwards. Do you notice that? So I'm going to flip it around right now, and that includes the inequality symbol. So this one is read out loud as -4 is greater than n. What that actually means is n is less than -4. This one says -1 is greater than or equal to x. The better way to write that is x is less than or equal to -1. Do not graph them until you flip them around, because if you try to graph them when they're the wrong way, your arrow will go backwards, because you'll look at this and you'll think greater than. You'll say, okay, greater than to the right. Ooh, it's not really greater than. That was written backwards. It's actually less than. All right, now that I've flipped those two around, I am going to graph them. All right, open circle or closed circle? That question is simply about, do I have the equal to part or not? I do not have the equal to part, so I match it up here. This symbol looks like this. I'm going to do an open circle to the left. So make sure you have these notes up here to yourself, because as you get used to this, you'll keep checking these and you'll look for, okay, open circle, closed circle, left or right. You can find the symbol that matches and then follow those directions. So this is, go to -4, that's the number. This is an open circle and it goes to the left. Open circle to the left. That's what less than tells me to do. Open circle to the left. Look at this one. This symbol, now that I've got it going the right direction, matches this symbol. So this is a closed circle to the left. So I'm going to go to -1, close that circle to the left. Closed circle to the left. Doing okay here? Let's keep going. I was trying to say let's keep doing this and keep going at the same time. So keep in mind, this whole thing is just about how do we make a visual representation to show what this inequality is saying. Number 5, is it backwards? No, it leads with the variable. Good, so I can just use this. It starts with the variable. The variable needs to be on the left. So this leads with the variable, so I find that symbol greater than, okay, here it is right here, matches with this one. So this should be open circle to the right. All right, open circle to the right. Perfect. Look at this one. Is this one backwards? Oh, yes, it is backwards. So the first thing I need to do is flip it around, including that. That's the most important part, to flip around, because now I'm not trying to match this one, I'm trying to match this one. So this one is open circle to the right. So I come to 0 and I do open circle to the right. Open circle to the right. Okay, here's what I want you to do right now. I would love for you to pause the video and try 7 through 10. I'm going to give you this hint first. Number 7 needs to be flipped around first. There you go, we flipped it around. And number 10 needs to be flipped around first. Those two are backwards, I just fixed them. These two are not backwards, so they are ready to graph. Pause me right now and graph those 4. Okay, did you try it? Let's see how you did. This one is an open circle to the left, less than to the left, less than to the left. And why is it an open circle? Because it does not have the equal to part. This one is a closed circle. Why is it a closed circle? because it has the equal to part. Greater than, to the right. Closed circle, to the right. This one is a closed circle. Why? Because it has the equal to part, so we are including 2. And the greater than means to the right. This one is an open circle. Open circle, because it does not have the equal to, less than, to the left. Be careful on any of those backwards ones, because can you see how if you hadn't flipped it around, you would think it should go to the right, and then you'd be showing me all the complete opposite of what you're supposed to be showing me. So for today, you need to be able to take a little inequality and you need to be able to show the visual representation of it. Keep this out as you work on your Canvas quiz so that you can match up and say, okay, is it open circle? Is it closed circle? Does it go to the left? Does it go to the right? Make sure this is out so that you can look at it while you work. But one more thing we need to be able to do is go the other direction. What if I already give you the graph and I'm asking you to write an inequality? That means you need to go backwards. So I'm going to tell you this right now. I'm going to start every single one of these with my variable, because I'm just going to write it in the correct direction because it would be silly to set it up backwards. So you might be saying, why did they put any of them backwards up there, Miss McGowan? Well, you'll see as we move through how sometimes you get to that backwards result and have to flip it around. But we'll save that for later. So the first thing I look at is open or closed. So right here, number 11, this is closed. What that means to me is whatever symbol I'm using, it's going to have the equal to part. So here's what I see. I see that this is closed and goes to the left. Okay, come up here. Which one says closed to the left? This one says closed and to the left. So because it's closed and to the left, this is the inequality symbol I need. All right, here I go. Closed and to the left means less than or equal to. And then I just need the number. Well, that's where the circle is. There we go. This graph is showing x is less than or equal to 2. Here's what I see on number 12. I see an open circle to the right. Look at the top of your paper right now and decide which symbol that is. Open circle to the right. Did you decide on greater than? Because that's what you should have decided on. X is greater than -6. X is greater than -6. Here's what I see on 13. Open circle to the left. Look up at the top of your paper. Open circle to the left, that is less than. Now I just find the number where the circle is, write it down. Number 14 is an open circle to the left. We just did that, that's less than. Open circle to the left. All right, last two. On 15, I see closed circle to the left. Look at the top of your paper and decide which symbol you need. Closed circle to the left. Less than or equal to 3. Look at number 16. I also see closed circle to the left. Less than or equal to 5. So today you are just practicing the visual representation for how to put an inequality on the number line. Focus on open or closed circle and do I go left or right. Keep your notes out because they will really help you.